Have you ever wondered why aeroplanes fly? It's actually quite simple, but it's a long story to get there. Before I do that, let me tell you something about a man called Sir Isaac Newton. He lived a long time ago, and he was a very famous scientist, and he formulated 3 laws. I don't know if you can see them here. Newton's laws of motion. And he said that if no force acts on an object, that was law number 1, then it will stand still, or it'll remain where it is. That sounds like common sense, doesn't it? So here you have this man in this boat, and there's the land. There's no wind, so it stays where it is, no current. His second law was that if a force acts on this object, it will either change direction or move or accelerate or stop. So if you see them on the boat and the wind starts to blow, that will blow him to the shore. That's the second law. Now the third law is a little bit more complicated. The first 2 were easy. The third law is that for every action there's a reaction. So for every force going that way, there's a force going that way, an opposite force, an opposite opposing force. And that's why if you're on that boat and you try to jump ashore, it's very difficult, because as you jump this way, you push back that way. So the chances are that the boat will go away, the land stays where it is, and you end up in the water. Now, that's something you have to remember as far as motion and aeroplanes is concerned. An aeroplane looks a little bit like that. Now, the engines push it that way, the thrust it's called. The air pushes against it, so it wants to stop the aeroplane. So that's called drag. There's gravity, which wants to pull the aeroplane down. Now, why does it fly? Well, it flies. Let me draw the wing. Let me draw it here. This is the wing. Have you noticed that aeroplane wings are flatter underneath than they are on top? So that when the air comes rushing this way, the air underneath the wing passes very quickly. Now, in nature, there cannot be a vacuum. So the air that's coming across here has to go further. This air goes in a straight line. This air has to go further to get here. And so it has to go faster to get to the same point. When it goes faster, it creates low pressure. It almost creates a vacuum. And so in here, it lifts the wing up, and that's called lift. So the wing generates lift. Now, if the lift is greater than the gravity, it pulls the aeroplane up in the sky. Have you ever thought, when you've been waiting for somebody, or you've been on an aeroplane yourself, that they've talked about a headwind or a tailwind? Let me explain how that works. If you're going to take off from this airport and you're going to that airport, and the distance is 120 miles. Well, if your airplane flies at 120 miles an hour, it will take 1 hour. 120 miles per hour. So it will take 120 minutes, and that makes, 120 miles an hour, it will go 120 miles in 1 hour. Okay? 120 miles an hour, it will go 120 miles in 1 hour. So that trip will take an hour. Now, if the wind is blowing against it, let's say the wind is blowing at 60 miles an hour, that's going against it. So you have to take away 60. So your airplane is only going at 60 miles an hour. So if it's only going at 60 miles an hour, 120 miles, it's going to take it 2 hours to do the same trip. Now if the wind is blowing with it, we don't take it away, we add it. 120 plus 60 makes 180. And if you're doing 180 miles an hour, then you're going to be there not in 2 hours, not in 1 hour, you're going to be there in 40 minutes. So if the wind is with you or against you, makes a big difference.